Hello, 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 hello. I am Mike, as I'm sure most of you know already. I've seen a lot of familiar faces today and some new faces as well. So yeah, I'm standing in front of the screen. Let's try this again. So I am gonna try and keep this brief because I think most of you know who we are, and I think it's yeah, in a nutshell, the raw essence of what we are and what we're trying to do is quite simple. So yeah, I'm just going to give you a brief run through, and then we're going to pass over to some of our sponsors to talk a bit more about what they do before we kick off. So this is my masterpiece that I put together for. It did not take me 10 minutes. um, so this is a very. I mean, there's no simpler way of saying what we do, basically. So this group was founded by myself and three others to essentially support any crossover between software and hardware in Brighton. So as I'm sure you're aware, and what I'll come to in a minute, is Silicon Brighton, who very kindly help us out with this meetup, with the venue and everything like that. They have many software groups, and some of the software group founders are in the audience tonight. It's where I started and where I met a lot of friends and things. But we thought that there was a real lack of hardware, basically. And I was meeting people at all of the software events that were saying, "Oh, I've got a Raspberry Pi. Oh, it's tucked away somewhere. I'll have to dig it out, and maybe we can have a pint and talk about it." And it never happens because everyone's got busy day jobs and lives and things. And that was kind of the birth of Silicon Brighton. So yeah, this is our last event of the year. So thank you very much for coming. Yeah, how many events have we done now? 4 or 5 this year? No, but this year. Fourth. This is our fourth this year. There are 6 next year. There you go. I am not the brains of the operation. It's thanks, John. Yeah, cool. So this is kind of a running order for the evening. This is generally how we run things. As you saw, there was pizza and drinks, which is normally something we run. Um, we are running a name badge competition, which is an ongoing thing. So anyone that likes to come to the events often, we encourage you to make a digital version of a name badge, and it's just a way of jumping off and getting people started, especially if you have little experience, or even if you have a lot of experience. It's a fun thing to do, and any and all ideas welcome. We've had ideas for the largest name badge and the smallest name badge, and yeah, the sky's the limit. So yeah, we normally run through those. Then we have a speaker of some kind. So tonight it will be lightning talks from the community. We thought it was a fitting way to end the year with kind of like having some of you lot speak, and there will hopefully be a short gap in between each of the lightning talks as well to kind of mingle and ask questions and all that jazz. And then at the end of the night, we normally try and find a local pub, just to whoever wants to, normally 25-30% of us kind of just mingle down the pub and just have a pint or two and just carry on the conversation. So this is something that we have been trying to work on, is our Slack channel. It's part of the Silicon Brighton workspace. I will move away from this in a minute, but we do have some QR codes on the corner here as well. We, amongst ourselves and with the few people that are in the Slack channel, we continue the conversation between the meetups. So, we share projects that we're working on, issues that we're having, events that we see, share news and all that kind of stuff. So we would love to have more people. We had a great attendance at all the events this year so far. I mean, the last one I was running around trying to find more chairs and things for anyone that was here. But we have a much smaller number in the Slack channel. So we're trying to move people into there as well so that we can have a bit more of a conversation and more community there between the events as well. Perfect. So just a quick, I'm sure a lot of you are really familiar with Silicon Brighton because they're a huge part of the tech scene here in the city. But they support, I believe is it over 30 still, or were you approaching 40? I think they're around 40 now, of all different meetup groups, as you can see here. And without them, it really wouldn't be possible. It would be possible, but it would be a lot harder to get things off the ground, to spark new ideas, and to just kind of have the luxury that we have of these amazing spaces and all this kind of stuff. So yeah, we really do have to say a big thanks to them. And these are some of the businesses locally that support them. So yeah, there's a few on there. You may work for some or know of them. And these are some of the bigger sponsors of Silicon Brighton as well. One thing I will say is if you can get involved with Silicon Brighton, please do. You know, what they do enables us to do this. So I know they're always looking for volunteers, and you know, they recently got their not-for-profit, so they're hopefully going into the next year with looking to get more funding and things like that. There's a big event coming next year, which we've got some slides to talk about later on. So yeah, definitely get involved if you can. Cool. This is a link to Silicon Brighton. So, you know, it's nice and simple, siliconbrighton.com for all the meetup events, what's coming, you know, if you want to find out a bit more or get involved or anything like that. One of the ones that I look forward to at the end of the year is there's a big Silicon Brighton festive meetup on the 11th of December. I was just trying to wrap my brain about where it is. It handily says right here. It's at the Old Albion in Hove. And that's where all of the meetup groups come together, the Silicon Brighton staff and anyone really can all go and just have a bit of a festive bash and yeah, get together. So yeah, I'm going to go along to that. So yeah, highly recommend. These are just a little taster of some things. I know we're approaching the end of the year now, but just some events that are coming up. Obviously, there's one on there that I'm quite biased towards. So make sure you, that's our next event is on the 21st of January. It will be here again, I believe. Is it? Thank you very much again. Yeah, so yeah, please put that in your calendar. The others are really great. I've been to the AI one, I've been to Async, you know, they're all really great. So yeah, just some dates to save. Perfect. Now I'm going to pass you over to Maya, who is here to help us with the space. And yeah, I'm sure she can speak up to it a lot better than I can.
Thank you so much for the introduction. So yeah, my name is Maya. I'm the community manager here. So for those of you who don't know, we're a co-working space. We have across the southeast coast, and we've got 10 spaces. This was the most recent one, but now we're opening one in Horsham, so that'll be our 10th space. And the goal is to get to the moon, so that is the goal. So what we offer meeting rooms, hot desks, dedicated desks, event space, and private offices. That all includes like Wi-Fi, free teas, coffees, biscuits, access to our community events, and our partnership with Barclays Eagle Labs as well, which is really good. And that's all on a flexible membership. So these flexible memberships are meant to allow businesses and freelancers like to get access to somewhere to work in the South Coast, where they can have access to a great community and where they can get peer support to help their businesses grow. And that's a big part of my job as well as community manager, to try and like cultivate that community. So we do this through hosting regular events such as this one with Silicon Brighton. We do a lot of events with them, and we love working with them because they do such great work. We also did a couple of the green SEO events as part of the Brighton SEO conference, which is a big event in the city. So that's really cool too. I also put on like shared lunches and regular charity cake sales, which everyone loves, as well as free beer Fridays, which is definitely the most popular one. So yeah, all of that is to kind of get people out of their offices and create community and to work together. That's what we're all about. And also Barclays Eagle Labs as well, as I mentioned earlier. That's a really great partnership that can offer free business advice as well. And that's why we say we're more than just a roof over your head too. So we like to say we're like, it's a work home. So if anyone wants to hear any more or is interested in booking the space, I've left leaflets around. Also, if anyone wants to speak to me directly, Cameron has my email address too, or you can just email through the website as well. But yeah, thank you so much.
Thanks, Maya. And Maya is really brilliant with helping to set up the events and making sure everyone's got all the practical things, teas and coffees and everything. So yeah, we really honestly, it wouldn't be the same without her help. So yeah, big thank you. Yeah, I'm going to pass you over now to our sponsor of this evening, which is Clockwork Dog. And yeah, I'm going to pass you to Chetan, who's one of the founders, but he'll also run you through this.
Hello. Oh yeah, thank you. We were looking for sponsors for Breaking Breadboards. We were like, who could sponsor Breaking Breadboards? And then at work, we were like, so I work for Clockwork Dog. And we were like, we're looking for people to hire. And ideally people that have like a little bit of an interest in like electronics and software. And we're like, hang on a minute. hang on a minute. So anyway, Tom is one of the founders of Clockwork Dog, so I'm just going to pass over to him and tell you a bit more about what they do.
Where shall I go here?
Not in front of the screen.
Okay. Hello, thanks for having me. Yes, thanks for that intro. So I indeed one of the co-founders of Clockwork Dog back in 2016. So we founded the company initially to run escape room events, which is what we wanted to do at the time. We were excited about escape rooms; they were new, and we wanted to run one, and we needed a company. So we set up a company and made a couple of pop-up short-term escape rooms. The second, by the way, I don't know what the slides are. So got it. Thank you. And then the second pop-up escape room we made in 2017 was called Loop, and this one had a lot more. It was a sci-fi theme, had a lot of sort of technical requirements. My background was in software developer, so I kind of created a system completely bespoke for this escape room, which ended up being the DNA for our product Cogs, which we sell now today to the industry, to the escape room industry and beyond. But back then, this was a bespoke system, which was a kind of software dashboard that allowed us to run the game, and it connected out to various bits of connected hardware all on the network, taking inputs from the players, dealing with things like audio processing and sending out all the various outputs, everything we needed to run this game. And back then our hardware was very much literally Arduinos and breadboards with jumper wires drilled to a bit of wood and stuck somewhere and hope it didn't get too dusty. Amazingly, we then sold that game and they ran it for nearly 7 more years with those exact Arduinos and jumper cables and breadboards, and it never went wrong, which I find incredible. So that's, yeah, was great. And basically from there, we wanted to keep doing this as a company and making experiences and events. But what we found actually is people kept coming to us and say, well, can you help us? You know, we want to do some tech, we want to do this and that. So we did a few bespoke systems for a few companies. Actually, some of the very, very first customers we ever had were actually in Brighton. So you may have heard of Bewilderbox, possibly, if you're into escape rooms. They're some of the earliest escape rooms basically in England. They had a game right back in sort of 2015. And they came to us for their game Judgment Dave, and they wanted various bits of tech. So we helped them build that. There's a very bespoke system. Again, not something at that point we were calling Cogs. That was just, we'll just build you a tech system, completely bespoke. There's also a company, Peer Pressure, in Brighton, who more recently have also started using all of our kits. So kind of well represented in Brighton, which is great. And then fast forward to today. So back then, yeah, our hardware, like I say, Arduinos and breadboards. We migrated to kind of a PCB, but that basically had an Arduino that went on the PCB, and then we had ribbon cables going to various components we needed. And then, year by year, we evolved. We learned. None of our backgrounds was actually hardware, so that was all self-learned within the company. Fast forward to today, our hardware is sort of custom PCBs running our various different bits of hardware. I've got some actually here because I've got a little mini show and tell thing. So if you're interested, I can show you how it works and maybe pop the top off. You can have a look at the PCB and go, ooh, stuff. And so as well as selling our kind of Cogs product, which is a software platform, which allows people who we're sort of coming in at a slightly higher level than people who want to actually, program Arduinos and do everything themselves. So we're coming at a level where the hardware is plug and play, and various bits of hardware to do different things. So we have input boxes for taking inputs from, digital sensors, analog sensors, RFID, that kind of thing. Output ones for dealing with things like media, so audio, video, etc., but also motors, low voltage DC outputs, etc., etc. And the software allows people to tie it all together and write the logic for whatever it is they're building, whether that's an escape room, an experiential event, immersive theater, whatever it may be. So that's kind of what our product is, and that's what we do today. We sell that to the escape room industry, but also immersive theater, like I say, kind of experiential marketing, that kind of thing. As well as sort of developing that product and selling that to the kind of community, we also internally work on a lot of sort of bigger projects where we get really stuck in. So we get clients who come to us and we basically help them deliver their creative vision. So that's often maybe some game design or also interaction design work up front and helping them develop those ideas. They're going right through pre-production, and then ultimately using a combination of our technology, the Cogs platform, but also sometimes we're building kind of custom stuff to go with it. And then we're there kind of installing testing, teching, and ultimately handing over. So some examples of stuff we've worked on recently: Paddington Experience in London, Viola's Room. We did a little bit of work for. It's a punch drunk show that recently closed in London. Top right there is Bridge Command, which is really cool. I encourage you to check it out if you don't know about it. But this is your opportunity to fly a starship. This is a show in London where basically you go as a group and you're group of the crew of a starship, and yeah, it all syncs up with a video game that kind of runs this space simulation, and that all talks back to our software, which then talks back out to the ship. So when you're being attacked, you know, the lights are going off and the sounds are happening, and it's really good fun. Saw Escape Experience, which ran for a few years. There was a kind of hybrid theatre escape experience based on the Saw IP. Also like Monopoly Life Sized, which is, if you don't know, that's another one in London, which is another one you go as a group and you are a team pitted against other teams, kind of playing a big version of Monopoly. It's more fun than it sounds. And various other ones. So that's like a big part of our work today as well, is like using our technology and other, you know, related technologies to deliver these kind of immersive and interactive technologies for live shows. And as Chetan said, we are hiring at the moment. So do check out our website, clockwork.dog. We're currently hiring for software engineers to kind of bolster the team and keep delivering more cool stuff. I think that's probably about it. Yeah.
Okay. Thank you. Thank you. Right. I'm John. I'm one of the founders, and this is a badge segment. It's where we get to talk to anyone who has made a digital badge and to share it and of what wonderful stuff they've made. And we can start by doing a little bit of an update on my badge. So my badge I talked about last time, which was basically a Raspberry Pi Pico. And one of the things I didn't like about my badge is it couldn't do video. So I've now fixed it and it can do video. That means that I've ditched the SD card because I couldn't pull the video fast enough from the SD card. And I've ditched the Pico and I now have basically what is a Pico 2. Actually, it's a Pico 2 Plus because I needed 16 gig of flash in order to store the video. But and me being me, it's Harry Potter themed. So yes, we basically have a badge with me moving my head slightly. So what other badges do we have? So I thought I see the world's biggest badge hanging on the wall over here. Okay, we'll leave the lightning talk. We will do that as a lightning talk. We have Chetan's badge here. So these different projects. Very interesting. Joseph, I think, you know, your joke badge, because I think we're running out of other badges to share. So this. You're right. Definitely. Phone badge 2.0. Yes, phone badge 2.0 will be very good. Right. In which case, that takes us into where are we going? Oh, where does that take us into? Events to think about. Why are these out of order? Okay. Yes. Sorry. Right. So let's move into the main show and tell, and I think we're starting with Richard. So we are going to do 10 minutes roughly of chat, and Mike will signal and then start throwing things at the end of the 10 minutes, and then we're probably going to take 3 or 4 minutes in between to kick everyone off and put the new stuff on. So just to let you know how we're going to roughly run. Yes, someone who's cleverer than me. Okay. Oh, and one microphone.
Right. Is that working now, John? There, up there. Right. Some while back, a few years ago, I was playing with processing. Anyone seen processing? Good, a few people know. I liked it because I'd done a lot of C before at work, and Java is a development from C, and so I could pretend I was just doing C, and the graphics is built in, and it's all wonderful. And at the same time, I was playing with Arduinos. Oh, that's the, sorry. That's the one. And this is something I built, and it was, I don't have the Arduino that this was talking to. And I think what I was doing here was temperature and humidity measured in one of those little dehumidifiers with a Peltier effect thing. And I've got things down here where I can, where's the mouse, where I can switch the fan on and off and the chill on and off and see how it works, which wasn't very well. So I could just about do everything I wanted with graphics and with Arduino and making them talk to each other, and that was all wonderful. And then one day I go back to the source. No, not there. Sorry, I've missed it. There, go back to the source. Processing is wonderful because you can just take a new image, a new IDE, and I looked up here, but I can't see it. There's something gone wrong with the screen size. I'm looking for a pull down at the top right, which was there before, but isn't there now. Have we got something? Ha! I can't see it. There should be a pull down at the top right where you can choose. No, it's gone. It's something to do with changing screen size and putting it on. Where you can choose to go into Python or JavaScript. And I thought, JavaScript, don't know anything about JavaScript. So I went into the JavaScript, and one of the nice things about processing is that it's got lots of examples. So I said, oh, what's this one? Now, in processing, when you run JavaScript, I don't know how this works. It creates a server somewhere inside your computer, and then opens a web page on the JavaScript program that you've just written. So that's an example. It's some kind of L system and mathematical thing. I could dive into that and get very interested, but there's no hardware, so we won't do that. So after looking at that for a while, I said, well, that's all very nice. It's a web page, but it comes up with a random port number here, random port number, and it's only temporary because obviously it's going to turn your computer off. It's gone. How do I put that on a Raspberry Pi? So I went online and asked, and I got directed to this series of 3 coding train videos. And there's about 40 minutes each one. You can go through it a bit quicker than that if you know what you're doing. And what the man ends up with, Dan Schiffman, what he does is builds a server out of Node.js and a web page, which is JavaScript on top of that. And his demonstration there is that you draw on one web page and all the other web pages that are clients of the same server, it draws on them as well. So you've got a pretty good base for building projects there because you've got server and web page talking to each other. So I did that, that's fun. And then I put it on the Raspberry Pi. Right, there it is. So you're drawing on the web page. Sorry, you have to click to draw. And if I'm lucky and everything is working, sorry, if I'm lucky, it's working. I've got the same web page on my phone. Is it drawing? Yes, okay. So that's the start. Everything communicating. Then you say, well, I've got Node.js running on the Raspberry Pi. What can I do with that? So the first thing I put on there was this pattern, which comes from one of the examples in processing for JavaScript. Very pretty. The lines at the top one is frame count moving along, and the next one is frame count that's been to the server and back again. So I know things are connected and working. Then you've got the pattern, and then I think, well, next thing you want to do with your JavaScript on the Pi is connect to the GPIO. So that's a library, and every time I go and do it, there's a different library that's in use and popular and working. I think the one I'm using now is called inout. And then you can build buttons, and I'll put a plug in for Coder Dojo because someone at Coder Dojo helped me build these JavaScript buttons. LED left on, light on the Raspberry Pi. This one's really for a younger audience. I'm astonished how well that works because it's the actual CPU that's producing the waves for the sound, and obviously it's busy doing other things at the same time. Okay, so we've got GPIO, we've got the JavaScript server. Move on. So then I wanted to connect to an Arduino, and again, you just load in another library, a serial library, into the Node.js server, and you can talk to your Arduino. It's 21 centigrade in here, humidity 48. See the vibration count at the end if we're lucky and everything's working. No, we're not. Bad connection, sorry. Right, we'll come back to that maybe. So we're talking serial to an Arduino. This is wonderful. Then, now libraries on the Node.js, they're not all fantastic. Someone somewhere has made a mess. And I tried to load in a library to talk to a humidity sensor. This humidity sensor is connected to the Arduino, but you can connect to the Raspberry Pi as well. And the library wouldn't load. It came up with errors. No one on the internet seemed to know how to fix it. So I used a Python program and learned about FIFOs on the Raspberry Pi, feed the values into the FIFO and make the JavaScript program read the FIFO. Right, gone around the problem. And that happened with a couple of other things I tried to do. I think someone here said Dallas 18B20, is that the name, the temperature sensor? Same thing happened when I tried to get that to work, and I had to use a different language, Python probably. Right, so yes, oh, Chart.js. There's another library called Chart.js which lets you build a graph, and that is not a very exciting graph, but it's the temperature and humidity for the last few minutes since I turned this thing on. The whole scale is 24 hours. Right, let's move on to the project. So this was a software story for the development of pieces that gives you a set of tools that lets you build any project really to control anything. The project I wanted to do was, I'd realized since I'd had solar panels that when I had more power than the house needed, I should be heating my water. So there was several things against this. The house, everything was in the wrong place. The hot tank was in the middle of the house, no power, no thermostat. The solar power measure was in the garage, and the electric measure was in the kitchen. So solve the heating problem with 100-watt resistors, which I'm using at 50 watts. Thank you. And the yellow things, the 3 wires, those are these Dallas temperature sensors. It's fantastic. 3 wires, instead of having previous eras, you'd have to have a wire to each one. And that's just horrible. Whereas this, the same 3 wires go along them all. Fantastic. And I put another 8 of them down the side of the tank as well. So now if you want to, you can lie in bed and see if there's enough hot water to have a shower. Okay, that's the energy monitor that E.ON gave me many years ago. Underneath it, it's got a serial port in a Cat5 socket. So I moved that to where the hot tank is, and the Raspberry Pi can connect to it. Raspberry Pi has serial on its GPIO. There they are marked out. Sorry, I shouldn't point my finger. There they are, TX and RX, and it's serial at 0 to 5 volts, the same as lots of other TTL serial devices, not RS232 plus or minus 12 volts. 2 minutes, oh dear. Right, let's go very quickly. The solar power measurement wasn't very good. It only came in every 6 minutes. So I put my own light dependent resistor on top of the flashing light and the meter, and another Arduino and another Raspberry Pi, which should really be an ESP8266. It would be simpler and better, but all right. These light dependent resistors are fantastic. Very cheap. They're better than people say they are. They say they're slow, but it can catch the pulse on your electric meter. That's the view of the whole thing. It could do with a tidy up, yes. Where are we going? That's the diagram of how it all connects together. I forgot to mention the UDP messages from one Raspberry Pi to the other. That's another library that goes with Node.js. That's the web page that controls the whole thing. So we've got tank temperatures up there, resistor temperatures down there. The ones that are yellow are on, the ones that are red are too hot. Enable and disable the whole lot. Okay, that's a graph of the tank, the resistor temperature and the tank warming up over the day. Where are we going next? The latest twist to life was that I needed a new gas boiler, and the man wanted a tank thermostat, and my wife didn't want me to take the bedroom floor up to wire from the tank to the boiler. So I run and I said, well, I've already got the temperature of the tank inside the Raspberry Pi. So I rummaged online and found this thing, which is a Shelly relay, which is a Wi-Fi controlled relay, which is made to fit inside an electrical box. And what the software in there is astonishing. It's got several methods of connecting to it, and you can build your own blocks and connect them together and write your own scripts. So everything your software is doing. Okay. I think we're just about. Yes, that was it. I'm just about.
I think I'm not the only one that's going to have a ton of questions for Richard right now. Yeah. Thank you so much, Richard. Yeah, absolutely. I want to know a lot more. So yeah. We'll have to get that's a talk right there. I now want to visit your house, Richard, and Perfect. Yeah. So we're going to take 3 or 4 minutes, grab a drink, mingle around, and then I'll give you a blast on the mic when we're ready to go for the next one. Who is the next one? Any volunteers? Yeah. Alessandra? Yeah, perfect. Yeah. We'll have you up next, and yeah, we'll sound a horn or something when you all need to be back. Yeah. Check, check, 1, 2, check. Imagine your best horn noise right here. Insert horn. Right, we're gonna rock for the next one. Whip, whip. Yeah, perfect. So we are going to hand over to Alex for his. Yeah, again, I'll just shout you if you're running over, but yeah, perfect. I'll hand over.
All right, thank you very much. Hello, everyone. Today I'm going to talk about my experience of creating a PCB, which is a carrier board for a Raspberry Pi compute module. So I wanted to ask you guys a couple of questions first, like who in here is doing electronics like professionally or at a good level to do something? They think they could do something like this. Yeah. So what I wanted to explain to you is like I'm an absolute beginner. This is not difficult. Yeah, I know. Well, I kind of cheated, but it is much easier than what people may think. This is what I mean. So what I wanted to do is to inspire people who I see a lot of people like they are kind of starting with electronics. I did a few kits like soldering them when I was a kid, when I was younger, and most of them did never work. So don't worry, keep at it. Like I have a vague idea about electronics, but I am a software guy. I'm not a hardware guy by any means. And my first PCB was for, I have a project that I'm working on. And my first PCB was kind of similar to this one in that it had these two connectors with a 40 pin connector for the GPIO. It was a glorified cable. It was nothing more than that. Like a few tracks, a ground fill, and that was it. This is more complex, but it is doable if you have something that requires either a microcontroller on board or a CM4, like in this case. It is less complicated than it looks like. That said, there are a few things that are complex. Like one of them is if you see these two connectors where the CM4 goes, they have 100 pins each on two lines, so 50, 50, 50, 50. So you have to keep your tracks quite small. And the other bit that makes this a bit complicated is what are called high-speed signals. So in my lack of knowledge, I used to consider the tracks on a PCB as small resistors that we don't really care about unless we have to drive a lot of current through them, in which case you make the tracks wide. This is different because there are some electromagnetic effects that you have to think about when you do HDMI and USB. So it is a bit more complicated, but I don't know the theory of it. I just through a bit of studying, a bit of understanding, a bit of copying other people's work, I was able to put this together and it works. So you need to know a bit about KiCad. You need to know a bit about how to put an electronics project together. But then after that, starting from your average PCB and going into something more complex like this one, it's just a matter of learning two new tools in KiCad. One is the calculator and the other one is to do length matching, because some of those tracks have to have the same length within a very small tolerance. But yeah, those are rules that are easy to learn to do something as simple as this. Of course, if you're doing a motherboard for a PC, it's a different job, I guess, different kind of job. But it is doable, so it's not as complex or as daunting as it may look like. And the reason why I went through this project is actually that for what I'm working on, at some point, I started from a prototype on a Raspberry Pi, and then I realized because I want this ultimately to become a product, I want something custom in its form, in what it has and what it doesn't have compared to a Raspberry Pi. And I didn't find anybody who would do it for me for cheap. I tried on Fiverr or these kind of things, but as soon as I was mentioning HDMI, high-speed signals, etc., everyone was super busy, and they couldn't accommodate my requests. So I thought, okay, let's see how difficult it is. I knew that what I'm trying to do is not complex for someone who has the knowledge, but how complex is it for someone who doesn't have the knowledge? And it turns out that it's not something as complicated as I thought. So yeah, this is pretty much what I wanted to talk about. Guys, it's of course learning a lot about electronics takes an entire life, but starting from doing a few kits and then moving to the next level and then learning how to design stuff, etc. You can do some pretty amazing stuff without having a lot of knowledge. And now I wanted to talk a tiny bit about the specific of this project. This is actually a small gaming console. So these two are for old style. I don't know who remembers this kind of joystick controllers. And there is HDMI, USB-C power, SD card, and a USB for like a USB hub. So the idea is you plug in your SD card, you play your games connected to these two old style game controllers. And this is part of a bigger project which has a very complex software part behind it. And the idea behind this is to, when we were playing games, video games when we were kids, on the 8-bit and the first 16-bit machines, they used to be much more responsive than current games. So current games, they have very beautiful graphics and they're very complex, etc. But there is a high latency, relatively high latency between when you press a button on a controller and when something happens on screen. More technically, modern systems are pretty much focused on throughput. How many things can we do in a unit of time? Instead, the old consoles, because they were not powerful enough, they had the luxury of having a very low latency, which is how long does it take for doing one little thing. And what I'm trying to do with this project, is to bridge the gap between these two kinds of different ways of playing video games. I don't know if by any chance you are interested in this. Maybe ask me later regarding the gaming side specifically. And yeah, if you want, I have a Facebook page. If I can, it's called the No Input Lag as a single word. If you want to have a look, it pretty much talks about the project that I'm working on. It's very small, and I use it to keep people informed about the progress of this project. So thank you very much for now. Are there any questions, any things you want to know? Hey?
You talked about KeyCAD.
Yeah.
So how crucial was that in designing that board? It's a N-layer board. How many layers?
This is a 4-layer board.
Yeah.
You need the 4 layers because otherwise you have to make your tracks so wide that you cannot do.
That sounds complex.
It's less complex than it sounds.
Right. So with the CAD, you use the KeyCAD.
Yeah, you need
with
to
the
learn
CAD
how to use the
files.
CAD.
So yeah.
And then it was manufactured by a Chinese manufacturer.
Right first time.
Eh?
They got it right first time.
Yeah. It works. All right.
Firstly, 4-layer isn't that complicated. They get a lot more complicated.
Yeah.
What were you going to do for a processor on it? What are you going to use for a processor? What were your ideas?
At the moment, there is the space for a Raspberry Pi CM4.
Right.
So
okay.
it's a-
So you're going was probably the most sensible thing to do,
Yeah, it depends.
unless you've got about a month to 6 weeks of time to pay for someone to do a DDR3 layup.
Yeah.
You know, it's
that's the point. I need, like, this is really, and this is why I thought it was so appropriate to talk about it in this environment, is really like moving baby steps in the world of high-speed PCBs. I guess you know well
a
enough.
little. Yeah.
Yeah.
I've done a DDR3
Yeah.
layup.
Yeah.
It's,
So
it's
that
quite clerical more than sort of technical.
yeah,
very
that's
clerical.
much more complicated than this, but this is a good starting point.
Oh, yeah,
I
yeah.
think. Yeah.
Thank you so much. And that is a great example of, I think the message there is really strong. And, it's what we promote hugely, is just trying to get started somewhere, building step by step by step, and not seeing huge, big projects and being daunted by it. It's really awesome. Yeah. So yeah, thank you, Alex. Yeah, perfect. So we're going to take another short break. I think we've got Tom next. Yeah, perfect. Yeah, brilliant. I will listen for the horn that we don't have. Check 1, 2, check. Horn. Awesome. So, whoever wants to listen to the talk, if we want to take our seats. And I am going to hand over to Tom for his very interesting, I'm very intrigued. Yeah, perfect. I think we're just about there. Perfect. I'm going to hand over.
Thank you. Hello again. So I lied earlier. I actually started the company and COGS because I wanted to make games for house parties. So that's the real reason why I started the company. So I was going to share with you a bit today about some of the kind of games I've created over the last 7-ish years. It's become a tradition at our house around usually a Halloween party. And each year I like to try and build something in our spare room just to sort of entertain the guests, I guess. I don't know. It's just become a tradition now. I kind of think that's the only reason people come. So kind of have to do something each year. And one year when we didn't really do an escape room, we did something a bit different. People were like, "What's the escape room? What's this? This is just not really an escape room at all." So anyway, yeah. And then I've brought something along which is just a part of one of the ones I did for this year's Halloween party. So I'll see if it still works. It sometimes kind of destroys itself because I didn't build it very well, but that's part of the fun. So going back, I tried to just very quickly find some pictures and stuff from previous ones. So the earliest one I ever did was a Stranger Things themed. They're usually sort of themed around something in that year that's kind of, you know, what everyone's talking about or what everyone's watching or whatever. So I think this was about 7-8 years ago. We did a Stranger Things themed mini escape room in our spare room. And this was using at the time kind of like, you know, I was talking earlier about the very early days of when we were building what became COGS. It was sort of this very early embryonic version of that. But that was definitely a lot of breadboards and just hacking things together. But that had various cool stuff like a moment where the room went to UV and you sort of revealed the Demogorgon, if you remember Stranger Things. And you had to like get this laser pen and shoot it in the eyes. And my favorite part of this, which it was not Stranger Things at all, but it's just something I really wanted to do. I just, you know, you get an idea and you're like, I need to make that happen. Which was a sort of linear actuator kind of hidden behind this board where you were attacking this Demogorgon. And I sort of hooked it up before each game so that it pulled the string of a party popper, which then popped over the top. And that was the sort of weird end to the game, just a sort of party popper going off in everyone's face, which I enjoyed. So that was where it all began. And then going forward in time, I've tried to find some quick pictures. So 3-ish years ago, maybe, we did Squid Games one, whenever Squid Games was the kind of thing of the moment. So this was less escape room. I don't know how well this will make sense, but this was the based on the first episode of Squid Game, if you remember it. So this is like red light, green light. So you'll notice theme here of using servos and boxes. I don't know, just kind of entertaining. So in this one, we had accelerometers built into the sleeves of these green hoodies. Each player had to run on the spot to kind of advance their track along these. So there's like addressable LED tape along the floor. And then if they were still running and caught when the, this was someone who just won. So if the head span and you were still running, then you don't die like in the show, you lose and so the points would go down. And then you had to try and kind of catch up again. So a lot of people would be like, I know Squid Games. Are you sure should I play this? Especially like friends of guests, like, I don't know you. This is weird. So that was really fun. Also entered this into a thing that ran a couple of years ago called the Escapade Arcade in London, which was a kind of exhibition of like alternate controller gaming. So a lot of like interesting, weird hardware things for running kind of games. So I entered into that. It was fun. So that kind of formed part of that exhibition as well. Which was really cool because I do these things just for fun, so it's nice to actually be able to exhibit it somewhere as well. That one was really interesting because I tried basically I ended up not really succeeding in a wireless solution. So these jackets had kind of Ethernet cables hanging out the back, which I had to sort of like sew into the jacket so they didn't kind of flap around. But yeah, just about kind of held together. So that was Squid Game. Going back a year, so last year, what was the big cultural event? It was Barbenheimer, of course, Barbie and Oppenheimer. So I don't know if this one will really make sense from pictures, but this was a Barbie and Oppenheimer themed Halloween party. So the escape room was as well. So I had lots of puzzles with. I don't know if you can see here, this is like Barbies with sort of RFID tags on their base, and you had to place them on this box in the Shout out to cardboard prototyping here as well. I think Chetan introduced me to this concept. I managed to build all this really quickly by just using cardboard and just stabbing holes in it and making it do what I want. And the main centerpiece of this one, which I think, yeah, this was this was the bomb that Ken had rigged up. And I think if I remember, you had to find the un-Ken-riched uranium, which were marbles, which you then put in the little chute. So an interesting one with this, I tried quite a few ways of detecting the marbles going in. So initially, and we use these in a lot of our own projects, we use like break beam sensors. So I thought that'll work great. Went in, all these see-through marbles didn't work at all because it's like, oh yeah, that's how those work. So I tried some other things like landing on a button, but they weren't heavy enough to really trigger any buttons that I had or micro switches. So in the end, I actually used a little like a little piezo module, which worked really well. So I managed to just about guide it so it would land bang on the metal bit of a little, I don't know if you've seen them, the ones, not like the ones that are housed as buzzers, but the ones that are just flat. And that produced a really nice readable little spike as a sensor input. So that worked surprisingly well as a kind of counter for putting these marbles in. Yeah, so that was Barbenheimer. And then this year it was, so I got inspired by, there's a new attraction in London, which I recommend. It's called the Escape Arcade, not related to the Escapade Arcade, which I mentioned earlier, but this is a kind of new form of escape room that's kind of taking off a bit. Sometimes they're known as like challenge rooms, but generally the way these work is you have lots and lots of mini 5-minute games. You go in as a team and there's lots of other teams playing at the same time, and you have an hour and you just run around and you find a room that's open. You go in, you scan your little RFID card, the room just begins and you play a little 5-minute game, and it's all about accumulating points. It's super fun, and because if you're not into it, it's over in 5 minutes and you just move on. So for this year, I was like, well, let's do something like that. So we'll build 3 games. So I ended up building 3 different games. So we had a pumpkin-based game on the balcony where you had to sort of throw ping pong balls into pumpkins. Back to the whole break beam conundrum, but this time I managed to get, they did break the beam because they weren't see-through ping pong balls. We had a kind of more escape roomy sort of wordy puzzle that you just had to figure out. And then this one, which was a kind of memory one. So this one was called Gymnastics. This was a kind of memory and communication puzzle, I guess. So what we have here, this was in one side of the room. What I don't have, because it's now in a recycling bin, was, well, I'll show you a quick video at the end, but it's a large sort of bit of cardboard that had a kind of picture of the same skeleton with the arms and legs in various positions and buttons on the arms and legs. And the idea is you watch the skeleton do its little dance, and then you have to kind of mimic it on the board. And they were set up so that, with the 2 of you, someone would have to communicate to the other person. So the person on the buttons couldn't see what this was doing. So I'll just quickly show you how this worked. And what you're seeing here is cogs, what we were talking about earlier. So this is our kind of software, the software side of our hardware platform. And this is currently running. So I'm just going to kick this off, see if it does something. We have lights. Might even get lights. There we go. It's doing something. So it basically plays a sort of haunted version of the Nutcracker, and then you then go, and I'm just going to fake doing the right thing here. So do the right thing. Got some points. And then we do a few of these. So this is the warm-up round. We have to just follow maybe one leg, one arm, but then it does get harder. Is it still like together? Oh yeah. And also this would keep breaking itself, but it's holding up for now. So now we're having to do 2 at once. I'm gonna get one wrong. That's a shame. So obviously we would get no points for that. And then eventually we'd move on, we'd have to do 2 at once. So here you'd have to remember the first one and remember the second one. Or 3 apparently. Yeah, I think the last round was you had to do 3 at once, and no one ever got that far. It was way too hard. Anyway, you get the idea. So that's sort of how it worked. It's also quite fun building this sort of audio, which was just like looking for lots of weird ways to make kind of music sound haunted, which is just sort of changing the like pitch randomly, adding phasers and weird stuff like that. So that was quite fun. And I thought, given I've got the opportunity and we've got the screen going, just to show you in the most whistle stop way ever, like what this looks like in the kind of software side of things. So if I go to connect here, so we're connected here to some of our hardware, which is hiding behind this box, but come and see me afterwards if you want to see how they work. But this is how we connect up to the hardware, which ultimately is then talking to, in this case, 2 servos and 1 DC channel talking to the LED strip. So we can see here where these are kind of connected to, and we can kind of play with these and see how they work. I can show you that with, let's go with, instant speed or whatever. So this is like a way of testing and setting all those limits. And the way this would be set up here is we would actually set certain positions. So here I've got my position 1, position 2, position 3, position 4, which I can then reference in the logic and sort of when I'm deciding, okay, we're going to move to, arm 2, leg 3, and I can just move to those positions. And then broadly, the way like logic and you're building up what you want to happen in the kind of cogs world is building what we call like behaviors. So I'll just jump to one just to give you a quick example. So this is behavior which basically triggers every time I want to do another dance move. So, and you can see it's all built out of these sort of like blocks. So it's a kind of, if you've used anything like those, I don't know, things like Node-RED or like Scratch, those sort of things, building stuff out of blocks, it sort of takes inspiration from that. So this is where we may be like triggering the audio and doing various things like updating states of variables and so on and so on. And you can see we can also drop down to kind of writing expressions in code as well. So we have that power to go a bit kind of deeper where we need to. So yeah, this is the kind of thing, it's kind of how it looks. Yeah, I don't expect that to make a huge amount of sense, but I just thought I'd give you a kind of quick overview of how this kind of gets built in cogs and how I like to use it to supercharge my house parties. And I'll just show you very quickly what this was the kind of counterpart to that, so you can kind of see what that meant. You'll notice the head there from the Squid Games. She's just sort of just in our flat now. Don't know what to do with it. So at this point, a different light would come on, and then you'd go off and press the button over there. So you can kind of see how that works. I'll just finish with one funny story, actually. So that papier-mâché head for the Squid Game thing my partner built, she does all the kind of crafts sort of to accompany these the games. And for the longest time after, like I say, we still got it. We didn't want to throw it away. We just sort of left it around the flat. And for the longest time, it was in the windowsill of our flat, kind of like looking out into and our flat. I don't know if you've seen like Rear Window, the Hitchcock film. But it's very much like that. We've got another flat block across there, and we can, you see into their flats. You can see people moving around the kitchen, and we don't know any of those people. We know our neighbours. So we had this head just sitting in the window. So it must be quite weird if anyone looks over. And then we, our house parties, people are arriving. One of people who actually recently joined our company, she came along, I invited her. She came with her friend. It happens to be her friend lives in one of those flat blocks. So they walked in, and one of the first things she saw was this papier-mâché head. She went, "Sharon, it's the head, people." So it turns out for over a year, they'd been like coming up with all these like explanations for who these weirdos were, who had this papier-mâché like girl's head in the window. And then she suddenly found herself trapped in their flat. She was like sort of horror movie setup. So that was very entertaining. So now I just leave this in the windowsill just to kind of, keep her company. That's it really. Yeah, thank you.
Yeah, thanks, Tom. That's awesome. What do I do to get an invite? Join the queue, right? Yeah, amazing. Perfect. Sweet. So we'll take another couple minutes and then we'll have our last speaker, which is John, with another creepy head. Yeah, perfect. if you want, or it's up to you. Or do you want to introduce yourself? Let's go on. DIY.
Right, 30 seconds. Oh, they're all running off now. 30, 29, 28. Have you not? Even I use one of those for my live streams. Oh, we need a 30-second countdown. You surely can find one off YouTube. Right, shall we take our seats for the final show and tell? Shall we take our seats for the final show and tell? So we've just had Halloween, which sort of was actually how that robot head, Santa head project started, because I started with that one at Halloween and then moved on to Robot Santa. But this project actually went the other way, because last time you were here, you probably saw my little skull, crystal skull that was sitting up there with the moving eyes and stuff. Well, actually, that didn't start as the skull. That started as my Christmas advent calendar. I just found how great these little tiny screens were and how easy they were to work with LVGL as a graphics language, and then they moved backwards and became nice moving eyes for a skull. So I wanted to talk about this particular project, which looks really, really complicated, but actually is much, much easier than what we've seen Alex do earlier and other things, because this is really just one of those touch screens, an RP2040 touchscreen, that then has a breakout off the back of it so that I can control a set of WS2812B LEDs. And the idea here is that each day going through Christmas, it is going to illuminate a different LED on the 3 Christmas trees, which will slowly build up until they get to the Christmas where they all go into nice fairy-like world. And each day, of course, there will be a different picture displayed on that little LCD display, which you can just about see down the front of the unit. It's a touchscreen, so you can click through them. Of course, you can't normally click through all of them because it hasn't got to the day. You can't see tomorrow's picture because that would be a spoiling, wouldn't it? So we wouldn't allow you to do that, so it stops you doing that. It's on demo mode at the moment, which is why it's going madly going. So every 20 seconds it goes through and it's the next day. You don't want to reset the date every day, so it does actually use a DS3231 real-time clock in there with a battery in the back as well. Other interesting anecdote and story, we were talking about soldering and how easy soldering is and things, so and designing these boards and things like that. I thought this project was way too simple to bother making a proper PCB for. So I would solder it all up on a prototype board. 8 hours later, I decided that this was a really, really bad idea. So the other one that's on the table is actually the prototype board, and it does all work and it's fine. But yeah, that took 8 hours. Designing the PCB for this, which is only a 2-layer PCB, so it's pretty simple. Designing it took less than an hour, even though I actually had to hard design some new modules in KiCad because things like logic level converters never quite fit. But then it's and actually soldering that once the board turned up 6 days later, that took me less than an hour as well. So generally, actually manufacturing a PCB was much easier than trying to solder it up on a prototype board. Do not think that prototype boards are easy. They are hard work to put together. So yes, the code for that, the hard bit of the code was understanding wave shares examples. Really, once you understand wave shares examples and you structure them in a way that actually makes somewhat more sense as a project, it's really quite good and really easy. And these are really easy displays to work with and fun. And I think I'll be using them in other places too. So there is lots more about the details, all the code, the 3D models for the printing it and stuff. I've all put on a repo, and I've got a YouTube video talking about that went out at 2 o'clock today, and one talking about the PCB design that goes out next Thursday. So if you want to, my channel is Dr. John EA. Please go and look at it, because that's how I pay the mortgage. So yeah, that was that, and I've done that really quickly in about 6 minutes, I think. So great, which gives us nicely time for us to move out to the closeout slides and things to say of stuff that's coming up. And I'm doing this a bit, am I? I've got the mic, so I'm in control. We do as we told. So thinking about next year, 2 things coming up next year that I wanted to mention and get group idea on. One is Maker Central. Maker Central is theoretically the big maker conference that goes on for amateur makers in the UK. It's in Birmingham, 17th to 18th of May. Be interested if people want to do something around that, want to do something with breaking breadboards, going there, linking up. Let me know, or one of the co-founders lower, and we can just take a sound and see what we can start to think about and arrange, why we've still got time to sort stuff like that out. And if you don't like traveling all the way to Birmingham, and it is a long way, then there is going to be a local conference run by our friends at Silicon Brighton on the 4th of July called Evolve. And if you've I don't know where you've been, if you've not seen it plastered all over LinkedIn. So Evolve will have lots of stuff in there, and breaking breadboards should be part of that. So we almost certainly will be trying to man some stands there and show some really cool projects. So if you've got projects that you'd like to show, ideas, start thinking about it, because you've only got 8 months. And it might take that long to go through a few revisions. Certainly mine do. So yes, so that's that. Our next meeting here will be on January 21st, and not fully confirmed yet, but sort of penciled in, is to have a main speaker from Dan Makes Things. If you've come across Dan from the world of YouTube, Dan has made an amazing companion robot, which doesn't walk around on 2 legs, but it does certainly stand and follow people around and things like that. So we will be chatting to Dan and his project and how he got to this world, hopefully. Whether Dan is here or not in person is to be confirmed, but that's where we're working on. And continue the conversation on Slack. Please join us on Slack. It's very lonely, because otherwise it's generally sort of Mike, me, Jeeton, and Hitchin, all sort of, liking each other's posts, really. It's quite lonely. So we would love to have as many of you on Slack as possible. Join us all on Slack. So yeah.
Check 1 2. One thing I just wanted to add, John, is I've taken some photos tonight, and we've taken some photos kind of across the events. I keep forgetting to post them, which is really bloody annoying. Yeah, just come and grab one of us at the end if you'd rather not be in the photos. I meant to say that earlier on. I don't know why anyone would want photos of them all over the internet anyway. That's dumb. So I always take the photos from the back of the room, like facing forward. Backs of heads are better than front of faces. You know what I mean? But just in case that's, obviously we do catch sides of faces and things generally. Yeah, just come and flag me down. And
look, there's nothing wrong with having your face all over the internet. That's this is how I make money. And amazingly, people seem to want to do it.
I walked straight into that one, didn't I? Yeah, absolutely. But yeah, I'm going to put those photos from each of the speakers and more information about the projects and things into the Slack channel. So yeah, just to kind of really kickstart it and yeah, just to get the conversation going. So yeah, feel free to give us a shout.
Cool. So we don't have to rush out. So time to mingle, chat, ask that question, find out all about Tom's parties, and get his address. Yes, thank you very much, everyone, for joining us, and have a great Christmas.